Welcome to the A&S Digital Pharma World. So today we can see the lecture 3 of Unit 1 Colloidal Dispersions. In this lecture 3, I am going to discuss about properties of colloids. Okay, so you know the properties of colloids as per our uh, syllabus. We want to learn what is optical properties and electrical properties and kinetical properties. Among these properties, one more property is there, that is physical properties of colloids. Okay, so we will see in detail about each and every properties. Okay, so let me start. Okay, so the properties of colloids are physical properties, optical properties, kinetic properties, and electrical properties. Okay, so physical properties of colloids. So physical properties of colloids means heterogeneity. Okay, heterogeneity in that colloidal solutions consist of two or more two phases, like dispersed phase and dispersion medium. Okay, and the next one is visibility of the dispersed particles. So you know these dispersed particles present in them are not visible to the naked eye, and they appear as homogeneous. So we want ultra microscope or electrical microscope to see the visibility of the dispersed particle. And the next one is filterability. The colloidal particles pass through an ordinary filter paper. However, they can be retained by animal membrane and cellophane membrane and ultrafilters. Next is stability. You know, lyophilic salts in general and lyophobic salts in the absence of substantial concentration of electrolyte are quite stable. Okay, and the final one is the color. So the color of the colloidal, which is depends upon the size of colloidal particles present in it, size and shape, you can tell. Okay, and the next one is we will see the mainly important one, optical properties of the colloids. Okay, so optical properties also they are asking for the 5 marks questions point of view. You have to concentrate it. Okay, so the optical properties of colloids. This is to study this study which helps to obtaining information regarding the shape, size, structure, and molecular weight of the colloids. Okay, the source of light and the resolving power of optical system mainly determine the precision and usefulness of such information. When beam of light strikes a particle, okay, it polarizes the atoms and molecules in it and induces dipoles in the particle. Okay, this dipole which emits weaker light at the same wavelength as that at the incident light. So the emitted light propagates in all directions, and this phenomenon is called as light scattering. You can see here, this is an incident light. When it will strike to an, this is the particle, when it will strikes to an particle, it it will in all directions it will get scattered. Okay, so this phenomenon we can call it as light scattering. When an incident light strikes the particle, it will get scattered. Okay, so this phenomenon we can call it as light scattering. So in the next we will see what is tidal effect. Okay, tidal effect or tyndall effect. When an intense converging beam of light which is passed through an colloidal solution kept in dark, okay, kept in dark, the path of beam which will get illuminated with a bluish light. Okay, the tyndall effect is due to the scattering of light beams gets illuminated light by colloidal particles. Okay, tyndall effect is not exhibited by true solutions. This is because the particles present in true solutions are too small to scatter a light. Okay, so we know in the colloidal system that's a crystalline, and it's a comparing to the true solution is a larger particles. So you see the beam of light. Okay, so the beam of light is passed through a solution which is kept in. See, in the true solution, the light beam, it is not showing anything. So it is not visible. And when it passes through an colloidal solution, when this light beam passes through an colloidal solution, it will show a bluish light. Okay, so light beam which will be visible in the colloidal solution. That's what we can call it as Tyndall effect. You can explain by this figure. Okay, and next one is, we'll see ultra microscope or dark field microscope. Okay, this is used to observe Tyndall effect. Dispersed particles appears as bright spots in dark background is capable of yielding pictures of actual particle size, shape and structure of colloidal particle. So the sample is placed at the apex of the cone where light intensity is high. After passing through the sample, the cone light, okay, the cone light diverges and which passes outside the incident light. Okay, some scattered light which will endures through to the objective of the microscope, and ultra microscope which is used to study the electrophoresis of charged particles, and which is, it helps in determining, okay, and which is also used to determine the zeta potential. Okay, then the last we will see what is light scattering method. Okay, so this light scattering method which depends on the Tyndall effect, which is used to give information about particle size and its shape, and for determination of molecular weight of colloids. Okay, and also is used to study the proteins association colloids, what is lyophobic souls. Okay, and the scattering describes in terms of turbidity. So what we will see now, what is turbidity? So the turbidity is nothing but the fractional decrease in intensity due to the scattering as the incident light passes through a 1 centimeter of solution. Okay, so the turbidity which is proportional to the molecular weight of lyophilic colloid optical properties of colloid. So we can represent as Hc by T is equal to 1 by M plus 2 Bc. Okay, where T stands upon turbidity and C concentration of solute in grams per cc of solution, and M is molecular weight, and B interaction constant, and H4 constant for a particular system. Okay, so this optical property is very very important. Okay, so first you must have to remember what is light scattering. Okay, when an incident light will pass through a particle, it will get scattered, that is known as light scattering. And Tyndall effect, Tyndall effect you have to remember, you will keep a colloidal solutions in a dark. Okay, so when a beam of light which passes through a colloidal solutions, it will show a bluish color, but when you passes through a true solution, it won't show any color, because the true solution, in the true solutions, the particle size are too less. Okay, and the next you have to remember what is ultra microscope. You know, to this is used to determine the shape and size of the colloids. Okay, and the last light scattering method, which is related to Tyndall effect, and it's used to about the information of particle size, shape and molecular weight determinations, and which will be described on the turbidity. Okay, this much you have to remember, and which will give you 5 marks. Okay, I hope you people understood. Thank you for watching. We'll see you in next video. Thank you.